Hello everyone, today we will learn chapter of function. Okay, there are a few parts of function that we need to learn. You need to know what is definition of function. Next, you need to know how to find the domain and range for different function. Then you will learn inverse function, and at last is composite function. So we will see one by one. So first part, we are learning what is function. Okay, so function, they relate x and y, and each x value must map to only one y value. If this criteria fulfill, then it is a function. So they will ask you which of these graph are function. We check one by one. So we check for one specific x value. Let's say my x is this. Let's say this is a 5. I don't care. Just draw a vertical line. If you found that it have 1, 2 y value, then this is not function, right? How about this? Each x value, it only have one y value. Yes, this is a function. Each x value have one y value. Yes, this is function. Each x value have one y value. So this is a function. Each x value, okay, 2 y value. So this is not a function. This is a function. Okay, so this is the first part. You need to know how to identify which thing is function, which thing is not. Okay, second part of this chapter, we need to know what is the idea of domain and range. Okay, so domain, if we know that all function, we actually able to sketch it in the graph. So domain refer to this graph, whether it can continue to go left or go right. What is the left, right? Okay, and then range will identify what is the up, down of the graph. So the way that I ask you guys to remember is domain is just like a dog. It can only run left and right. It cannot fly up, down, right? So that's why domain, left, right. We see, okay, let's say for this graph, x plus 2. What is the domain? So we see this straight line, can I continue to go left? Can continue to go left, continue to go left. Agree or not? No restriction on left. I can continue to go right, go right, go right, go right. Also no restriction. So if I can go left and right without any restriction, we just write our domain x is every real number. This is representing all real number. Then how about the range? Range we see up, down. Okay, so this thing I can continue to go up. Agree or not? I can continue to go up. This part I can continue to go down. So actually up, down also no restriction. So if I can simply go up and down, then it's also ER situation. Okay, just that for range, you need to name them based on the name of the function. For example, here they tell you this function is called fx. Then we say f is all real number. So next we see the gx part. Okay, gx equals to x squared. If we sketch out, it looks like this. So we see, we identify the domain first. Domain, can I continue to go left? Yes, I can continue to go left. Can I continue to go right? Yes, I can continue to go right. So left, right, no restriction. So again, is ER, X, ER. Domain is always X. Huh? Okay. So how about range? Range is up, down. Can I continue to go up? Yes, I can go up, 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 up. But can I continue to go down? No. There is a minimum value that it can reach. Then after that, it can no longer go lower than it. So what is the minimum that it can go? Minimum it can go is 0. Minimum it can go is 0. So that's why, and our name of the range is G. So this is G. Okay. So I'm above 0, right? So it's Bonham. And then this position is my curve passes through the 0. Yes, it passes through. So if it passes through, we will put the equal sign here. So G more than or equals to 0 is the range for this graph. After we know what is the domain and range, next we go to the questions that if the question already tell you a specific domain, they already restrict a domain for you. which as previously we know, x plus 2 is everything. X can go left, can go right freely. But now, if the question already tell you there only one x more than 0, x is 0 is here. They want when x is 1, when x is 2, when x is 3, which means they want this part. But they don't want anything on the left. So the graph, since it's restricted domain, the range will get affected also. So can our graph continue go up? So can I continue go up? Yes, I can continue go. So I can continue go up. But can my graph continue go down? Can I go down? No, because here, I start from here. Here is already my minimum. You see, I cannot go down. No. Okay, so we found that this is already our minimum point. So our range name based on the name of function. So my range is f, and then my minimum is here. So what is this point? Okay, so we go and sub in the x value, which when x is 0, the whole equation is x plus 2, so it's 0 plus 2. My y is 2, means that this position is 2. All right, so I know that 2 would be my least value. I can all the way go up, so it's x, f more than 2, f more than 2. We see another example. Example is here. They say x squared is this U-shaped graph. X squared is this U-shaped graph. So they say they want x more than 1. So restricted domain. So we need to do, first step, we need to go and sub in my x equals 0 to this equation. So g1 equals to 1 squared. Okay? So I'll get my answer is 1, which means when x is 1, my y value is 1 also. And then this question, I want more than 1, means I want everything to the right, the 2, 3, 4, all the way go to the right. So I only want this part. I only want this part. Okay, I only want this part. So I remove this part. So I only want the pink color part. Then I identify my range. My range, the name of this graph is G. So I can continue go up or not? Yes, I can continue go up. But can I continue go down? No. I have a minimum point. I cannot further go down. No. So I can only go up all the way from 1. So that's why here confirm is 1. Next, we need to identify more than 1. Should we put the equal sign? We refer back. They say x more than 1. I do not include this point. I do not include this point. See or not? I do not have the equal sign here. So here also don't have equal sign. My range is g more than 1. These two type of question is a simpler type question because can you see they are directly proportional type graph. This graph is here is when x increase, y increase. And then here, x more than 1, so x increase, y also increase. It's a directly proportional situation, so it's a simpler type. And most IG's question actually ask the simpler type question, but they also expect you to know some harder type question. Why is harder type of question? Let's see, because for this graph, it's still the U-shape, but they request x less than 1. We continue, we sub in x value is -1, okay, -1. Then we found that it's 1, which means when x is -1, my y is 1. I want everything go to the left, means I want -2, -3, -4, so I only want this part, agree or not? I only want this part. So, can you see, when my x decrease, my y increase. So they are not directly proportional. They are inversely proportional relationship. So that's why we cannot write G, we cannot copy back less than 1. We cannot copy the relationship, but inversely relationship, so our symbol also need to swap. More than 1. Okay? So because it's inversely proportional situation. Therefore, the next question also, this is the reciprocal graph. This reciprocal graph involves the asymptotes. When we key in x is 2.5, you key in the calculator, 2.5. You found that it is math error. Means that x equals to 2.5 is actually the asymptotes. Asymptotes is the line that the graph will never able to touch. Okay, same to this. For the reciprocal graph, you have one more asymptotes here. So they say x more than 2.5 means they only want this part. I can infinitely go up, but go down, it blocked by my asymptotes. That's why my graph is from 0 all the way go up, but do not include 0. So that's why my graph f more than 0. All right. So this is the harder type of question when it's not directly relationship. Be extra careful. And if you face any problem, please feel free to comment and seek for my advice. Thank you. After done everything from domain and range, now we go to the third part, which is inverse function. So inverse function we already learned in maths, but now we'll go a bit more. You need to know when will a function able to have inverse, and how to find the inverse function we already learned in maths, how to find the domain and range for inverse, and how to sketch the graph of inverse. Let's go one by one. Inverse question part 1. Only the function that is one-to-one function can have inverse, which means one x value maps to only one y value. So it's not only focused on one y value, but they also emphasize on one x value. See how we identify. Okay, we use this x line to confirm whether it's a function or not. If this question is not a function, then no need to see it. Confirm don't have inverse. Next, this is a function. We check whether it can have inverse. We're using horizontal line. This horizontal line just nice cast to one x value. That's why it can have inverse. It's one-to-one function. This is a function. When we confirm whether it's one-to-one, we draw a horizontal line. It cut through two x values. So it's a function, but no inverse. Next, this is a function. We confirm by using horizontal line. 1, 2, 3. No inverse. Cut to 2 point. Not even a function. It's a function. It cut through one x value, so it's also have the inverse. So this is how you confirm which function can have inverse. Okay, so we already know quadratic usually is a function that don't have inverse. But why many questions they will ask you to find the inverse function for this? Why a quadratic that usually don't have inverse can have inverse? If this quadratic, we do some changes which we restrict the domain. We restrict the domain. Means instead of the whole U shape, if I only want the more than 0 part, we want one of the part. We don't want both. We want one of the part. Can you see? It will become one-to-one function. So you need to know if we want a quadratic to have inverse function, we must do restrict domain so that it become one-to-one function. Okay. Next, we need to know how to find the inverse function. This thing we already learned in maths. We need to change the subject. So for this graph, we know that y initially is 4 ln 2x minus 1. So to change the subject to make it inverse, we need to make x as the subject. So we slowly throw the thing until x is the subject. So we throw 4 first. Then we remove ln, shift ln will become e. And then anything here will become power. So this is the relationship between how you remove the ln. And then we have 2x minus 1. And then minus 1 become plus 1. At last, we remove the 2. So we successfully change the subject. And after you successfully change the subject, remember to name your inverse function. And remember, this is the inverse function of x. So make sure here you also write x. Then you successfully get inverse function. It's just like your maths, okay? So next we go to the third part of inverse function, which you need to know how to find the domain and range for an inverse function. This thing you haven't learned in maths, okay? So for my method, I will recommend you to list down the original function's domain and range first, okay? So let's read the question. It says the diagram shows the graph of these, which f is defined as this. So they're telling you the domain is from 0 to 3. So first thing, we list down the domain for the origin graph is from 0 to 3. The information that I haven't get is the range of the original graph. We subs in our 0 and 3 into the function. F0 equals to, so you get is 0. F3 is this. So we already know the range is in between 0 and 9/4. Then we can confirm the range is from 0 to 9/4. The name of the range is F. So we already gather sufficient information. Then we can know what is the domain and range for inverse. So the relationship is just the domain of the original graph will become the range of the inverse graph. So the 0 and 3 you fit in here. And then the range for original graph will become domain of inverse graph. So 0 and 9/4 here. Then for domain, it's always x. For range, you need to base on what is the name of the function. The name of function here is f inverse. Then you know what is the domain and range of your inverse. Then we can go to the next part. Next, we go to the last technique of inverse function, which you need to know how to sketch the inverse graph and original graph together on the same scale. So first of all, you need to know what is the relationship between the original graph and inverse graph. Original graph and inverse graph, they have a geometrical relationship on refraction on y equals to x line. So every time you want to draw the original graph and inverse graph, you need to have a y equals to x line because they are showing a reflection. Before we draw the inverse graph, we must go and draw the original graph first. They say this is the original graph and their domain given is x more than -3/2. I usually will sketch at the side first. And since they restrict the domain is -3/2, then I substitute in my f -3/2 is how much? It is a max arrow. So when you found that it is a max arrow, you can confirm this line is actually an asymptote. Okay? So after you know asymptotes, the long graph looks like this. It will very close to the asymptote, but will never touch. And it continue like this. Okay? After that, the questions also mention you need to state the intercepts on the coordinate axis. What does that mean? It means that you need to clearly tell me what is the x-intercept and y-intercept. We need to do some calculation. X-intercept means y equals to 0. 0 divided by 5, still 0. Ln show here will become e power 0. And then e power 0 is 1. Plus 3 show here become -3. So -2. The 2 show here become 2. So you can confirm your x is -1. Next, we find what is our y-intercept. I erase here. So to find a y-intercept, x equals to 0. F0 equals to 5 ln 3. And then if you key in calculator, you found that it's 5.49. So you already know what is the x-intercept and y-intercept. Then you can put your figure into your answering part. And make sure when you label your x-axis and y-axis, the skew need to be almost the same. Here is -1. Here is -3/2. So here will be 1, 2, 3, 4, 5. Only if your x skew and y skew is almost the same, then the function that you draw out will look symmetric. So the first coordinate is here, the next coordinate is around here. So your graph looks like this. Okay, and then how about your inverse function? So your inverse function, you just write down what are the coordinates that you know for your original graph. So the coordinate that you know for original graph is -1, 0, and 0, 5, ln 3. So after you know these two coordinates, you know what are the coordinates for the inverse function, which you just swap the x and y. So the first coordinate for your inverse function is 0, -1. The second coordinate for your inverse function is 5 ln 3, 0. 0 minus 1 is here, and then 5 ln 3 is around here. And then can you see the original line actually intercept with y equals to x line? So this would be our another point also, because when the original graph touch y equals to x, then the image, which is the inverse function, will also touch on the same point. So make sure you know that. Then you just join them. Yes, you see a symmetry shape up here. Then you just label this is your fx, this is your f inverse. This is how you sketch an inverse graph. Last part of function, we need to know how to do composite function, which this we learn in maths. How to do the composite function. For example, this is gfx. If it's gfx, I will put in my value of fx here first. So I know fx is secant x, then I will replace my fx here. Then refer my g function. My g function, if x change to secant x, this x also will change to secant x. So it is 3 secant x squared minus 1. So this is how we do composite function. Is exactly like your maths. So the part that we haven't learned, which is new to MS, is if gfx exists, what is the domain for gf? If they already tell you gf is exists, then you just go and find what is the domain for the inner part. The inner part domain will decide what is the domain for your composite function. So inner part is this. So my domain for gfx is just the same. Very easy. Last, the question might ask you to define whether this composite function, whether it exists or not. Or like this question, they will ask you, explain why this composite function does not exist, okay? So in this situation, you need to know the outer part, we need to refer back to the domain. The inner part, we need to refer to the range. And we already have the domain for gx, x less than 4. So now we need to go and find what is the range for the f. How to find? It's just subs in. So we found that it's 0. So we can confirm our range is more than 0. The inner part should be able to fit into the domain of outer part. So we have a look. The inner part, they say they want more than 0. The outer part, they say they want less than 4. So can the inner part fit into the outer part? Cannot. So it doesn't exist. So the explanation that you should write is range of fx unable to fit in domain of gx. Then you successfully explain this situation. So this is the end of the chapter of function. Thank you for watching. And if you have any question, feel free to comment or find me to seek for more advice. Thank you.